Okay, so in this class, we're going to be exploring some more useful properties of logarithms in addition to the definition. So last class, we learned the definition that log base b of x equals y means b to the y equals x. So this is just a new way of writing this information. Okay, so here we are. Our first property of logarithms is that the log base b of a product x times y is equal to log base b of x plus log base b of y. So we're going to verify that this property is true for log base 4 of 64. So I want to calculate log base 4 of 64 using the definition of a logarithm. So 4 is my base. I need to figure out what exponent I raise 4 to make 64. So log base 4 of 64 is whatever power you raise 4 to make 64. So if you don't know this off the top of your head, you might have to do a little bit of guess and check with a calculator. So I'm just trying to figure out what power to raise 4 to make 64. So maybe it's simply not squared because 4 squared is 16. So let's try cubed. 4 cubed is 64. There we go. So log base 4 of 64 is 3. Is it true that 64 equals 4 times 16? Yes. Okay. So I want to calculate log base 4 of 4 using the definition of a logarithm. So 4 is my base, right? This 4 is my base. To what power gives me 4? Well, that would be the first power. Log base 4 of 4 is 1. Write that out. Log base 4 of 4 equals 1. And log base 4 of 16 is asking what power do I raise 4 to make a 16? Well, that's a 2. 4 squared is 16. So now log base 4 of 4 plus log base 4 of 16 is 1 plus 2, which is 3. And my answers to parts A and E should match because log base 4 of 64 is the same thing as log base 4 of 4 times 16, which is log base 4 of 4 plus log base 4 of 16 according to my properties, and that was 3. And I said this equals 3 from the very start. So you get 3 both ways, so we verified the property. Okay, second property, log base b of x over y. If you want to take the log of a quotient, you can expand that to taking the difference of two logs, log of x minus the log of y. So we'll verify this property for log base 3 of 9. So log base 3 of 9, using the definition of a logarithm, is just asking what power should I raise 3 to make 9? And the answer would be 2. Is it true that 9 equals 243 divided by 27? Yes, you can check it on a calculator, but it's true. All right, I want to calculate log base 3 of 243 using the definition of a logarithm. So log base 3 of 243, I need to know what power to raise 3 to make 243. I don't know off the top of my head. Let's see, 3 cubed, 27. 3 to the 4th is 81. 3 to the 5th is 243. So log base 3 of 243 is 5. And log base 3 of 27, oh, I did 3 cubed earlier, and that was 27. So log base 3 of 27 is saying, what do you raise 3 to make 27? And it's the third. All right, so now I'm going to subtract log base 3 of 243, that was 5, minus log base 3 of 27, that was 3, and I get 2. My answers to parts A and E should match. Right? Check. My answers to parts A and E should match because log base 3 of 9, which I know is 2, should equal, according to this property, log base 3 of 243 over 27, just replacing 9 with a more complicated way of writing 9, 243 over 27, which now, according to my property, should be equal to log base 3 of 243 minus log base 3 of 27, which was 5 minus 3, which is 2. And I know that log base 3 of 9 is 2 from the definition. So verified the property. Okay, third property. Log base b of x to the p is equal to p times log base b of x. So I'm going to verify this for log base 2 of 1024. Log base 2 of 1024 using the definition of a logarithm. So I need to know what to raise 2 to make 1024. And I believe it's 10. Let's see, 2 to the 10th. Yes, is 1024. Okay. Is it true that 1024 is equal to 4 to the 5th? Yep. Okay, so now I want to calculate log base 2 of 4 using the definition of a logarithm. So 2 to what power gives you 4? The second power. And then 5 times log base 2 of 4. So 5 times 2 is 10. And my answers to parts, oh, what was I doing over here? Log base 2 of 1024 is 10 because 2 to the 10th is 1024. And now my answers to parts A and D match, thus verifying the property. All right, and number 4, last one. Log base b of x is equal to log base a of x divided by log base a of b. This is called the change of base formula. It's really handy because you only have 2 different log buttons on the calculator, log base 10 and log base e. So I'm going to verify this property is true for log base 5 of 125. So I can calculate log base 5 of 125 in my head because 5 cubed is 125. So log base 5 of 125 is 3. But if I use a calculator, if I wanted to use a calculator to evaluate log base 5 of 125, I can't type it in directly, but I can use the change of base formula to change it to base e, right? So I would just take log base 5 of 125. I can take the ln of 125 divided by the ln of 5, and I get 3. Same thing I got when I used the definition. And I can do the same thing with any base. I can use base 10 also. Log of 125 divided by the log of 3. Oops, 5 equals 3. So using the definition and the change of base to 2 different bases all give me the same answer. Okay, so now you have an activity applying log rules. You're going to use the rules that we just discussed and verified to expand or condense some expressions. So I'll do one of each of these. Log base 2 of 2x. Well, 2x is 2 times x. So that is a product. So I can expand that to log base 2 of 2 plus log base 2 of x. And then I can simplify. Log base 2 of 2 is 1 because 2 to the first is 2. Log base 2 of x. And now I've expanded that. So we're going to do a similar thing, applying the log rules, the new log rules, to A through F. And then in part 2, you're going to apply the log rules in reverse to condense each expression. So let's do B here. Log base 2 of 5 minus log base 2 of 7. I can use the log rule in reverse. I've got the log base 2 of something minus log base 2 of something. So this would be equal to log base 2 of a quotient 5 over 7. Okay, so I can use the rule in reverse to condense each expression into a single log. And then I'll let you read through the challenging your creativity part and do that on your own.